Breaking news from the far edge of our solar system. 3I Atlas is no longer behaving like a simple comet. Only days ago, as it crossed within 2 astronomical units of the Sun, astronomers watched in disbelief as its brightness climbed far beyond every prediction. Its atmosphere has expanded until it now spans nearly half the diameter of our star. Its glow has shifted into an unsettling green. And most disturbingly, it has developed a tail pointing directly toward the Sun, something once thought impossible. As it races toward Mars at breathtaking speed, researchers are forced to admit they cannot yet explain what they are seeing. The countdown to perihelion has begun. With each passing hour, this interstellar wanderer looks less like a comet and more like a riddle carved into the fabric of the cosmos. Stay with us through the end of tonight's exploration to uncover what this breaking story means for our understanding of the universe and what happens when alien chemistry awakens for the very first time. The numbers do not lie, even when they defy reason. In mid-September 2025, monitoring stations across the globe reported something unsettling in their data. 3I Atlas was climbing off the charts. Predicted magnitudes of 15 to 16 had suddenly collapsed to 12, even 14. To those unfamiliar with astronomical magnitudes, this may seem small, but in astronomy, every step lower means an exponential leap in brightness. A drop of just 2 magnitudes means the object is now producing 6 times more light than expected. And this was no gentle curve. It was acceleration. The Comet Observation Database began filling with data points rising sharply above every standard model. Earth-based tracking confirmed it. 3I Atlas was shining brighter than any path ever constructed for its journey inward. The tipping point came as the object crossed in 2 astronomical units of the Sun, still twice as far from the Sun as Earth itself. At that distance, something fundamental changed. The acceleration was not only unexpected, it was alarming. What could force such a dramatic surge in luminosity? The most likely explanation lies in volatile ices, frozen carbon dioxide, water, and exotic compounds locked inside its nucleus since the moment of its birth around another star. As radiation intensifies, these materials do not melt gently. They erupt, sublimating straight from solid to gas, carrying dust, rock, and debris, swelling into clouds that reflect sunlight back into the void. But rapid brightening is rarely benign. Outgassing events can fracture a comet, shattering it into fragments and clouds of debris. They can also exhaust its volatile reserves in a single burst, leaving only a dark husk behind. The fact that 3I Atlas is brightening faster than any model predicted suggests we are witnessing processes astronomers do not yet understand, processes that may never have been seen within our solar system. And yet, there is no reason for panic. NASA has confirmed the comet will never pass closer than 1.8 astronomical units from Earth, nearly twice the Earth-Sun distance. The danger is not collision. The danger is ignorance. We may be watching an interstellar time capsule unravel before our eyes, a body forged in the debris disk of another star, traveling for millions, perhaps billions of years through the void, now facing the Sun's heat for the very first time. Exotic ices and alien molecules, preserved in silence since its birth, are awakening. For humanity, this is not a threat, it is a revelation. And this revelation arrives with dates carved into stone. October 3rd, its closest approach to Mars, just 30 million kilometers away, close enough for spacecraft orbiting the red planet to glimpse details invisible from Earth. October 29th, perihelion, the closest approach to the Sun where its true nature may finally be revealed. But fate is cruel. At the very moment of its peak activity, 3I Atlas will be swallowed by the Sun's glare, hidden from every telescope on Earth. Only the mechanical eyes orbiting Mars may remain to witness what could be the most spectacular chemical awakening in interstellar history. The story of 3I Atlas begins not with drama, but with a faint whisper of light on a mountain in Chile. On July 1st, 2025, the asteroid Terrestrial Impact Last Alert System, better known as ATLAS, captured a dim smear of motion across the stars. At first glance, it was nothing special, just another point of light cataloged among thousands. But within days, the truth emerged. This was no ordinary body. It was moving too fast, cutting across the heavens on a trajectory that could never be bound to our sun. The orbital math told the tale with ruthless clarity. 3i Atlas was following a hyperbolic path, a one-way journey. Once it swings around our star, it will never return. Its speed, its geometry, its freedom from solar gravity confirmed the extraordinary. This was only the third confirmed interstellar object in human history. The designation carries meaning. The I stands for interstellar. The number 3 marks its place in the short list, after 1 Oumuamua in 2017, the elongated Enigma, after 2 Borisov in 2019, the more familiar comet with alien chemistry. Now comes 3 Atlas, and like its predecessors, it refuses to play by any known rules. The discovery itself was nearly lost. Recovery images, archival frames taken weeks earlier, showed that Atlas had been drifting through sky surveys unnoticed, its significance unrecognized until algorithms flagged its trajectory. This delay is common with visitors from beyond. They masquerade as asteroids at first, only later revealing their cometary veils. But when larger telescopes turned their eyes toward it, the picture sharpened. The Hubble Space Telescope caught it in July. The Very Large Telescope in Chile joined in. They found a faint coma already swelling around the nucleus. Remarkable, considering it was still more than 3 astronomical units from the Sun. Most comets wait until far closer before shedding their icy skins. This one was active in the cold. Its size remained elusive. Was the solid core a mere 300 meters or as large as 5 kilometers across? No one could say. The coma blurred the nucleus, hiding its true proportions. But its speed was unambiguous. At over 130,000 miles per hour, 58 kilometers per second, it was moving faster than any native comet ever could. By perihelion, it may surge to more than 150,000 miles per hour, a velocity earned only by drifting for eons through the tug of countless stars. That velocity is its signature. It is proof of birth beyond our sun. No orbit within the solar system can gift such momentum. It carries the kinetic imprint of its journey across the galaxy, sculpted by stellar gravity and galactic tides. The rarity cannot be overstated. In the whole of human history, before 2017, interstellar visitors were only a theory. Now we have 3, and each has rewritten the rules. Oumuamua bent light curves with unexplained accelerations. Borisov carried ices never stable in our solar system. Atlas now adds its own riddle, an atmosphere too vast, a tail that points the wrong way, a glow of alien green. And so the classification matters. This is not a stray comet from our Oort cloud. This is a fragment of another system, an emissary from a nursery of worlds that may have long since vanished. It is not just debris, it is evidence. A piece of planetary birth frozen light years away, preserved for billions of years, now unraveling in the heat of our star. As October 3rd approaches with its close pass by Mars, instruments in orbit there prepare for a chance unlike any other to see up close what Earth will soon lose to the sun's glare. Because 3i Atlas is more than a comet, it is a message, one written in ice, dust, and alien chemistry, and like all messages from the stars, it will not linger. Time is running out, both for 3i's Atlas and for the astronomers racing to decode its story before it vanishes back into interstellar night. Orbital mechanics, cold and precise, have already drawn the map of its brief passage. Every milestone is fixed, every date is written, and the window to witness its secrets is brutally short. The first critical marker falls on October 3rd, 2025. On this date, 3i Atlas will sweep past Mars at a distance of just 30 million kilometers, barely 0.2 astronomical units. In cosmic terms, that is an intimate encounter. placing it within easy reach of spacecraft already orbiting the red planet. For the first time, machines built to study Mars may find themselves turning outward, capturing glimpses of a body born around another star. But the geometry is both gift and curse. Just as Atlas approaches Mars, offering the best vantage point humanity has ever had of an interstellar visitor, its position in Earth's skies will be sliding ever closer to the sun. The cruel glare will soon overwhelm telescopes on the ground, forcing astronomers to watch helplessly as their chance dissolves into daylight. By late October, the second marker arrives, perihelion. On October 29 to 30th, 3i Atlas will make its closest approach to the Sun, roughly 0.36 to 1.40 AU. This places it slightly inside the orbit of Mars, subjecting it to a radiation intensity unlike anything it has ever experienced across millions of years of interstellar drift. The heating will reach its maximum. The comet's chemistry, its structure, its very survival will be tested in fire, and yet, this critical moment will come cloaked in blindness. From early October through early November, the comet falls into superior conjunction, a time when its apparent position lies too close to the sun's disk for Earth-based telescopes to see. It is the astronomer's nightmare, the greatest transformations happening in plain sight but drowned in the brilliance of the star that causes them. Its speed tells its own tale of extremity. Already traveling tens of kilometers per second, by perihelion 3i Atlas will reach an astonishing 68 kilometers per second, over 150,000 miles per hour. Compare this with Earth's orbit, a modest 30 kilometers per second. Atlas is moving more than twice as fast as our entire planet races around the sun. That velocity is not a local gift. It is the echo of its galactic voyage, accumulated over millions of years under the gravity of stars and the turning of the Milky Way itself. The trajectory slices neatly through the ecliptic plane where most planets circle the sun. This alignment explains its proximity to Mars and later its distant brush with Jupiter in 2026. Such geometry is rare. For a visitor from random interstellar directions to align this closely with planetary orbits is a cosmic coincidence of breathtaking value. One thing is certain, despite early fears, there is no threat. NASA has confirmed that its closest pass to Earth will be a safe 1.8 AU, nearly twice the Sun-Earth distance. The real drama lies not in planetary danger, but in the race against light, time, and orbital angles. For astronomers, the message is clear. Their greatest questions may be answered in October or forever lost in the weeks when Earth will be blind. Velocity is more than a number. It is the comet's biography written in motion. Every kilometer per second tells the story of the forces that shaped it, the gravitational pulls of distant stars, the subtle tides of the Milky Way, the long drift through cold interstellar dark. At present, 3i Atlas is racing through the solar system at over 130,000 miles per hour, already far faster than anything born in our neighborhood. But by the time it sweeps through perihelion at the end of October, that speed will surge to an incredible 68 kilometers per second, nearly 152,000 miles per hour. To place this in perspective, Earth itself, a massive world anchored in stable orbit, glides around the sun at about 30 kilometers per second. 3i Atlas is moving at more than double that pace. Its sheer velocity makes one thing certain: once it slings past the sun, it will not return. This is a one-time visitation. That speed is not a quirk, it is a fingerprint. Local comets gain their velocities through the pull of the sun or gravitational assists from giant planets. But nothing within the solar system could have launched Atlas to such speed. It carries the imprint of a much older journey, momentum accumulated over millions of years, drifting from star to star, nudged and pulled until it arrived here, at our doorstep. After perihelion, gravity will slow it again. The same sun that accelerates it inward will decelerate it as it departs. But its fate is fixed, a long outward arc that will never bend back. By March 2026, the comet will brush near Jupiter's orbit, offering one last distant chance for spacecraft observations before it fades forever into the black between stars. For astronomers, this timeline is both a gift and a wound. It means that for a brief season, we stand at the crossroads of two galaxies, our solar system and the alien birthplace of Atlas. But it also means there is no second chance. Unlike periodic comets that return every few years or centuries, 3I Atlas will never circle back. The clock is running, and the universe will not reset it. The cruelest twist is the timing of superior conjunction. Just as solar heating reaches its peak, Earth will be blinded. Observers on the ground will watch it slip into the sun's glare, like a candle engulfed in floodlight. The most explosive transformations, outbursts, fragmentation, chemical revelations, may all occur hidden from our eyes. And by the time the comet reemerges in November skies, much of the story will already be over. The future of discovery lies not with Earth, but with mechanical eyes scattered through the solar system. Mars orbiters designed to study the red planet now find themselves pressed into service as humanity's only witnesses to one of the most profound encounters in astronomical history. As orbital mechanics write their equations in stone, one truth lingers. This is a once-in-a-civilization event. An emissary from another star has come, blazing fast, leaving us only weeks to understand it. And when it departs, it will take its secrets back into the endless night. The most astonishing revelation about 3I Atlas is not simply that it comes from another star. It is the sheer, impossible scale of the atmosphere it has built around itself. In September 2025, NASA's Sphere-X telescope detected something that defied every model of comet behavior: a coma, an envelope of gas and dust, stretching more than 348,000 kilometers from its nucleus. To imagine this size, consider this. The cloud surrounding Atlas is now half the width of the Sun itself. It is large enough to swallow Mercury's entire orbit. This is no ordinary comet. This is a spectacle without precedent. A coma forms when solar radiation strikes a comet's frozen nucleus, forcing its ices to sublimate, transitioning violently from solid to gas. Dust and debris are carried outward, scattering sunlight into a glowing veil. Astronomers often describe comets as dirty snowballs, but in reality, they are far more violent, cosmic grenades whose surfaces vent and fracture in the face of starlight. Yet the coma of 3I Atlas tells a story unlike any comet native to our solar system. Its composition is dominated by carbon dioxide, not water. This reversal is extraordinary. Local comets are built from the icy leftovers of our own protoplanetary disk, where water was abundant and CO2 secondary. But Atlas was forged in an alien nursery, one cold enough, far from its parent star, that carbon dioxide froze more readily than water. Its coma is not just massive, it is structured in ways that baffle physics. Images from the Hubble Space Telescope revealed a plume pointing directly toward the Sun. Comet tails, by every law of radiation pressure, should stream away from it. For millennia, this has been the defining feature of comets. Yet here was Atlas, breaking the rule, displaying what astronomers call an anti-tail. At first, some suspected an illusion, projection effects caused by viewing angles. But as weeks passed, multiple observatories confirmed the anomaly. The anti-tail persisted. It was not a trick of perspective, it was real. How could this be? Theories emerged. Perhaps unusually large dust grains, heavy enough to resist solar wind pressure, were being ejected sunward with explosive force. Or perhaps the nucleus itself was rotating in an exotic pattern, venting jets of gas along pathways no ordinary comet could sustain. But none of these explanations fully account for the clarity, scale, and stability of the sunward plume. This is not simply a comet behaving strangely. It may be a new category of object altogether, a body whose chemistry and physics were sculpted under conditions Earth-based science has never modeled. Spectroscopic measurements only deepen the puzzle. Gas streaming from the coma is moving faster than expected, at velocities far beyond those of comets at similar solar distances. Temperatures in the coma do not match predictions either. Infrared data hint at reactions, perhaps the breakdown of exotic ices, perhaps the release of energy trapped in crystal structures formed under interstellar cold. The coma is asymmetric, not spherical. Jets burst from isolated regions, implying a patchwork surface, zones rich in volatile material exposed by impacts or stress during its journey. The dust it carries is coarser, stranger than that of solar comets, consistent with the world forged in a very different chemical kitchen. The closer Atlas drifts toward the sun, the more its coma expands, the more its structure shifts, the more rules it bends. For scientists, it is exhilarating. For our models, it is devastating. Because if comets from other stars routinely behave this way, then everything we think we know about comet physics is built on a narrow sample, a local bias in a galaxy filled with far stranger truths. In mid-September 2025, 3 Atlas underwent a transformation that left astronomers stunned. Almost overnight, the comet turned green. Not a faint tint, not a subtle hue, but a vivid emerald glow that spread across its swelling coma, turning this interstellar traveler into a lantern adrift in space. Photographs from telescopes across the world confirmed the change. During the lunar eclipse of September 14th, when the moon's shadow provided darker skies, cameras captured an unmistakable emerald halo around the nucleus. Against the star-speckled darkness, Atlas no longer looked like an icy fragment. It looked alive. The physics behind this glow lies in quantum mechanics. When molecules absorb the sun's ultraviolet radiation, their electrons leap to higher energy states. As they relax, they emit light at precise wavelengths. In the case of Atlas, that wavelength was around 516 nanometers, the signature of diatomic carbon, C2. 2 carbon atoms bound together, fluorescing like a neon sign in the void. This is a familiar trick among comets. Many glow green when carbon-bearing molecules are freed and energized. But in Atlas, something is off. Earlier spectroscopic studies suggested it was dominated by CO2 and water vapor, with little sign of the carbon-rich compounds that normally create such colors. So where did this sudden green halo come from? One possibility. Atlas crossed a hidden threshold as it fell inward. When it passed 2 astronomical units, solar heat may have opened fresh reservoirs of carbon-bearing ices, buried deep since its birth around another star. Dormant for millions or billions of years, they erupted into space for the first time, igniting the emerald glow. The timing is suspiciously precise. The surge in brightness that startled astronomers in mid-September coincided exactly with the shift to green. 2 mysteries, likely one cause: the violent awakening of alien chemistry. But there may be more here than simple diatomic carbon. Comets are chemical zoos, carrying dozens of complex molecules. Some are known, others may be unique to interstellar nurseries. The green hue could be a blend of fluorescing species, including compounds we have never cataloged before. What makes this glow even stranger is its unevenness. In some images, the emerald light is brighter in certain regions of the coma, dimmer in others, as if jets of gas carried their own unique chemical signatures. This patchwork pattern suggests localized eruptions on the nucleus, vents that spew carbon-rich gases in bursts, then fade, only to awaken again. To scientists, the glow is not just beautiful, it is diagnostic. Its intensity, its spread, its fluctuations over time all reveal conditions within the coma: density, temperature, collision rates, molecular interactions. By mapping these variations, astronomers are beginning to trace the comet's 3-dimensional structure, building a picture of alien chemistry in action. And yet, there is urgency. The emerald light may reach its peak during perihelion, precisely when Earth-based telescopes will be blinded by the sun's glare. What happens to Atlas's glow in those hidden weeks may remain unknown forever. For now, one truth stands out. The green light of 3I Atlas is not just a spectacle, it is a signal. Molecules born in another star system, preserved in frozen silence for ages, are finally awakening under our sun. The comet is no longer only an object, it is a laboratory, a place where the chemistry of another world is lighting up before human eyes. The universe has a way of revealing its greatest secrets at the very moment we are least able to see them. For 3I Atlas, that moment is now. As the comet grows brighter, stranger, and more alive with alien chemistry, orbital geometry is conspiring against us. From Earth's perspective, its path is sliding closer and closer to the sun's position in the sky, and soon, no telescope, no matter how powerful, will be able to separate the faint emerald glow of Atlas from the blinding brilliance of our star. This period is called superior conjunction. To the human eye, it is as if the comet vanishes into daylight. To the astronomer, it is worse. The one time in history when Atlas is at its most active, its most volatile, its most revealing, yet completely invisible from the ground. Even our greatest instruments are powerless against the geometry. The James Webb Space Telescope managed to capture precious spectroscopic data on August 6th, but only before the September transformations that changed everything. Hubble delivered high-resolution images of the strange sunward plume in July. But now, as the comet approaches the sun's glare, even these orbiting observatories must turn away. Their instruments are designed to protect themselves from solar damage. They cannot look into the fire. Ground-based observatories fare no better. The scatter and brightness data across September reflects more than just the comet's volatility. It reveals the challenge of measuring anything so faint near the overwhelming sky glow of dawn and dusk. Atmospheric scattering, instrument limitations, calibration errors all combine to blur the signal. What emerges is a patchwork of light curves that all agree on one point. Atlas is brighter than predicted. But how much brighter and why remains maddeningly uncertain. For amateur astronomers, the challenge is even steeper. Their smaller instruments, battling turbulence, pollution, and weather, can barely hold on to the signal. And yet, their contributions are vital. Continuous monitoring from backyards and small observatories provides the long-term coverage that professional facilities cannot always sustain. Together, these scattered data points paint a portrait of something real, a comet that is refusing to behave. But geometry is merciless. By early October, Atlas's angular separation from the sun, the elongation, drops below 30 degrees. By mid-October, it falls under 20. At that point, observation from Earth becomes effectively impossible. The comet will still be there, boiling and transforming under solar fire, but for us, it will have vanished. The irony is sharp. Just as solar heating reaches maximum intensity, just as outbursts, fragmentation, and chemical revelations are most likely, the comet will be hidden behind the glare. The universe has drawn the curtain at the climax of the play. From that point forward, the burden of observation shifts entirely to mechanical eyes beyond Earth. Mars orbiters built to map a world of dust and stone now face the unexpected task of watching an interstellar visitor unravel. They are not designed for it. Their cameras, spectrometers, and sensors were calibrated for the Martian atmosphere, not for faint comets racing at interstellar speeds. But they are all we have. For astronomers, the frustration is palpable. Every night of observation lost is a revelation stolen. Every degree closer to the sun is a curtain closing. And when perihelion comes, when Atlas is at its peak, the Earth will be blind. The quest to understand 3i Atlas has become as much about human persistence as it is about the comet itself. Every photon matters. Every fragment of data could be the key to unlocking its mysteries. Yet as the comet falls deeper into the sun's glare, astronomers around the world are fighting a battle against time, physics, and the limits of technology. Different observatories produce different results. Brightness measurements, photometry depend on weather, calibration, and atmospheric conditions. The same comet on the same night can appear brighter or dimmer depending on the telescope that measures it. This scatter is not unusual, but in the case of Atlas, it is magnified by the comet's rapid, unpredictable changes. What looks like an error in one dataset may be a real outburst in another. Websites like COBS and SkyLive attempt to reconcile these fragmented reports, charting them against theoretical models. Again and again, the conclusion is the same. Atlas is brighter than it should be. But by how much and for how long? The data, stitched together from hundreds of observers across the globe, are both a lifeline and a source of frustration. As elongation shrinks, the battle grows harder. Ultraviolet emissions, so vital for identifying key molecules, are the first to vanish, scattered by Earth's atmosphere. Infrared instruments can see further, but even they begin to fail when the comet lies too close to the sun. Observers are forced to wait for dusk or dawn, capturing only a few fleeting minutes before the sky brightens. Each night, those windows grow shorter until they disappear altogether. Coordination becomes critical. Telescopes in Chile, Hawaii, the Canary Islands, and Australia must work in relay, passing the baton from one hemisphere to the other, squeezing every possible observation out of the narrowing window. International teams trade data in real time, hoping to construct a continuous record before the comet slips into invisibility. Amateurs join the fight too, their backyard telescopes contributing invaluable continuity. Though their instruments cannot rival professional observatories, their persistence fills in gaps. Together, the professional and the amateur form a global net, straining to hold on to Atlas as it fades into the solar floodlight. Yet even the best coordination cannot fight geometry. By mid-October, the comet is lost. The greatest surge of heating, the most violent transformations will unfold in silence, hidden behind the curtain of the sun. For astronomers, it is a bitter truth. The very moment when Atlas may shatter, flare, or reveal its deepest chemistry is the moment when Earth must look away. And so hope shifts outward, to the orbiters circling Mars, the spacecraft not built for this task, but thrust into it by circumstance. Humanity's ability to understand this interstellar wanderer may depend not on the mighty observatories of Earth, but on distant machines orbiting a rust-red world, catching glimpses of a visitor from the stars. Beneath the careful language of scientific papers and the cautious tone of press releases, a different current is spreading through the astronomical community: concern and even alarm. For months, astronomers expected 3I Atlas to behave like a comet, perhaps with a few surprises, as interstellar visitors often do. But now it is breaking the script altogether. Its brightness curve is not just drifting from the models, it is soaring above them, far beyond the range of typical uncertainties. Multiple independent systems confirm the same unsettling truth. Atlas is shining brighter than it should, faster than it should, and in ways that no model can yet explain. Scientists are trained to be careful with their words, yet in quiet interviews and private exchanges they admit, this is something different. Dr. Matthew Knight, a comet specialist, has said that the rapid brightening observed in mid-September challenges the very foundations of our heating models. The speed of change, he noted, is faster than our assumptions allow. In other words, our understanding of how comets wake up under sunlight may be incomplete, or, in this case, completely wrong. And the green glow? It has deepened the mystery further. The chemistry doesn't match expectations. The anti-tail pointing toward the sun adds another layer of confusion. Each new observation doesn't close questions, it multiplies them. Among astronomers, excitement and unease walk hand in hand. On one side, the thrill of studying something unprecedented, a visitor carrying chemistry from another star system. On the other, the fear that, because of the timing of its perihelion and conjunction, humanity may never fully understand what it is. The comet's activity levels are not just unusual, they are extreme. Its carbon dioxide-dominated coma stretches farther than any seen before. Its gas velocities exceed expectations. Its outbursts come too quickly, too violently. This is not subtle deviation. This is a body rewriting the rules in real time. Still, some urge caution. They warn of outburst bias, the tendency of comets to flare unpredictably, giving the illusion of long-term anomalies when in fact they are short-lived events. A comet can brighten in days, then fade just as quickly, fooling observers into believing something extraordinary has occurred. But the clock is ticking. With perihelion hidden behind the sun's glare, if Atlas undergoes its most dramatic transformation while Earth is blind, we may never know the truth. The atmosphere in the scientific community is tense, a mix of excitement, skepticism, and urgency. For many, there is the unshakable feeling that this is not just another comet story. This is something more, something rare, perhaps something we will not see again in our lifetimes. The deeper astronomers look into 3I Atlas, the stranger it becomes. Every attempt to explain its behavior seems to lead into contradictions, forcing researchers to stretch their models or abandon them altogether. The sunward plume, the so-called anti-tail, is one of the sharpest puzzles. Yes, anti-tails have been observed in rare comets before, but never like this. The plume of Atlas is persistent, bright, and structured in ways that defy projection effects or simple dust mechanics. To make sense of it, scientists are proposing exotic scenarios. Perhaps unusually large dust grains launched with impossible speeds, or a nucleus spinning so slowly that one side bakes and vents violently while the other freezes. Others suggest that its surface may contain alien ices that react to sunlight in ways we have never seen. Meanwhile, its chemical fingerprint refuses to align with expectations. The balance of carbon dioxide to water vapor is unlike anything in our solar system. Is this simply a reflection of how different its birthplace was? Or has its chemistry been reshaped during millions of years drifting between stars? The answer is locked inside its coma and may vanish before we can extract it. The urgency of the situation is sharpening global collaboration. Telescopes in Chile, Hawaii, the Canary Islands, Australia, and beyond are coordinating their schedules, squeezing every possible observation from the shrinking window. Scientists from NASA, ESA, and independent observatories are sharing raw data almost in real time, united by the knowledge that this is a once-in-history chance. Amateur astronomers are playing a vital role too. With professional facilities limited, smaller telescopes, operating from backyards and mountain ridges, are filling gaps in the record. Their observations may not have the precision of Hubble or Webb, but together they weave a continuous thread of monitoring that professionals alone could not achieve. And yet, even this network cannot overcome the cosmic irony. As Atlas nears perihelion, Earth will go blind. The most critical moment when solar heating peaks and the comet's true nature may reveal itself will be hidden behind the sun's brilliance. Dr. Carrie Holt of the European Southern Observatory has called it a cosmic conspiracy against science. Still, hope remains. The Mars orbiters, not built for this purpose, yet perfectly placed, may become humanity's only eyes on the most important phase of Atlas's journey. If their instruments can adapt, if the geometry aligns, they could capture data that Earth will never see. For astronomers, the stakes are clear. Interstellar visitors are unimaginably rare. In the entire history of science, only 3 have ever been confirmed. Each one has rewritten the rules, and now Atlas is writing its own. To lose this chance would not just be frustrating, it would be a wound, a silence where there should have been answers. While Earth prepares to lose its view of 3I Atlas in the blinding glare of the sun, another world is moving into perfect vision. On October 3rd, 2025, Mars will host humanity's closest encounter with an interstellar visitor, an event that may give us our only clear look at this alien wanderer in its most volatile phase. The geometry could not be more fortunate. As Atlas passes within 30 million kilometers of the red planet, just 0.2 astronomical units, several spacecraft are already circling Mars, each carrying instruments never designed for this purpose, but now thrust into the role of cosmic witnesses. The European Space Agency's Mars Express, launched back in 2003, still carries its high-resolution stereo camera, capable of mapping the Martian surface in extraordinary detail. Repurposed, it could capture faint images of Atlas's coma, perhaps even subtle structure in its jets. The Trace Gas Orbiter, part of the ExoMars mission, was built to sniff out methane and study Martian atmosphere, but its Nomad spectrometer and Cassis imaging system could just as easily turn outward, searching for chemical fingerprints in Atlas's vast carbon dioxide-rich cloud. NASA's Mars Reconnaissance Orbiter carries HiRISE, a camera so powerful it can spot objects less than a meter across on the Martian surface. From millions of kilometers away, it may still resolve details of Atlas's nucleus, details that Earth-based telescopes could never hope to achieve. And then there is MAVEN, designed to study how solar wind strips away Mars' atmosphere. Its instruments, built to measure plasma and magnetic fields, may be uniquely suited to track how Atlas interacts with the solar wind, revealing hidden truths about the comet's internal structure. This unexpected fleet scattered around Mars suddenly finds itself in the perfect place at the perfect time. Together, these orbiters could provide humanity with its only clear data during the weeks when Earth will be blind. But challenges remain. None of these spacecraft were designed to chase a fast-moving comet against the stellar background. Their pointing systems are optimized for a large nearby planet, not a faint interstellar traveler racing at interstellar speeds. Atlas, at best, will appear as a dim smudge on their instruments. At worst, it may be too faint to detect at all. Success depends on timing, geometry, and luck. If the comet brightens again, as it did in September, its coma may swell bright enough for even Mars's instruments to capture. If not, the window may close with little more than silence. Still, hope is high. For the first time in history, multiple spacecraft on another planet will attempt to study a visitor from beyond the stars. If successful, the data they return could answer questions Earth can never touch. And so, as Atlas races past Mars, a quiet drama will unfold. Human-made machines circling a distant world, straining their instruments toward the green glowing veil of a comet that was born around another star. The potential of the Mars flyby is breathtaking, but so are the challenges. None of the orbiters circling the red planet were built to observe a comet moving at interstellar velocity. Their cameras, spectrometers, and sensors were tuned for Mars, its surface, its atmosphere, its weather. Now, they must adapt to track a faint object racing against the star field at over 130,000 miles per hour. Pointing systems are the first obstacle. Orbital spacecraft are designed to lock onto large nearby targets. But Atlas will appear as nothing more than a dim speck drifting across space. The orbiters must reconfigure, turning away from Mars and fixing their instruments on the darkness, following a moving target that was never part of their mission plans. Signal strength is another problem. Even at its closest, Atlas will remain faint, its brightness hovering near magnitude 12 to 14. That is far dimmer than what most of the instruments aboard Mars' orbiters were designed to capture. The comet's green glow may barely register. To succeed, the spacecraft will need the comet to cooperate, perhaps by erupting in another burst of activity, brightening enough to cross their detection thresholds. Yet, if these challenges can be overcome, the scientific reward would be extraordinary. High-resolution imaging could finally pin down the true size and shape of Atlas's nucleus, ending debates that place it anywhere between 300 meters and 5 kilometers wide. Spectroscopic data might uncover alien molecules invisible from Earth, chemistry preserved since the comet's birth around another star. Magnetometer and plasma instruments could record how the solar wind interacts with Atlas's massive coma, revealing the hidden structure of its atmosphere and perhaps the conditions of its surface. And the unique geometry from Mars's orbit could resolve the great puzzle of the antitail, showing whether it is truly material flowing sunward or a projection trick seen only from Earth's vantage point. The flyby also offers a rare chance to see how the comet's structure evolves under different solar phase angles, the shifting perspectives between sun, comet, and observer. From Earth, the view is nearly lost to glare. From Mars, the geometry is clean. If the instruments succeed, we may see the comet's coma and tail as no human eyes have ever seen them before. But expectations must be tempered. Even under the best conditions, the data will not resemble the sweeping, high-definition imagery of Earth-based telescopes. It may be only a handful of images, a few spectra, and measurements faint at the edge of detectability. Still, those fragments could be enough to change our understanding of interstellar visitors forever. Because this moment is unique. For the first time, spacecraft orbiting another planet may become our only witnesses to an alien body's closest brush with the sun. And for humanity, those distant eyes may record the only clear truth about 3 Atlas before it vanishes back into the dark between stars. The mathematics of celestial motion have no mercy. As 3I Atlas hurtles toward its closest approach to the sun, the geometry of the skies conspires to rob us of our view. By early October 2025, the comet's elongation, the angular distance between it and the sun as seen from Earth, drops below 30 degrees. This is the danger zone. At this separation, scattered sunlight drowns out faint signals. By mid-October, elongation slips below 20 degrees, and for ground-based observers, the comet effectively disappears. It does not vanish in an instant. Instead, it fades slowly into the brightness of day. Each night, observers catch less and less, until one evening the comet is simply gone, swallowed by the sun's glare. This is superior conjunction, when the sun and comet align from Earth's point of view, placing the comet behind a curtain of light too brilliant for even our most advanced instruments to penetrate. The timing is merciless. Perihelion, the comet's closest pass to the sun, arrives on October 29-30th, right in the heart of this observational blackout. The moment when solar heating reaches its maximum, when Atlas may outburst, fragment, or transform in spectacular ways, will occur almost entirely unseen from Earth. It is a cruel irony. For centuries, astronomers have marveled at comets in their most dramatic phases, flaring, splitting, and painting the sky with long tails. Now, with an interstellar comet unlike any seen before, the universe has drawn the curtain. At the very climax of the play, the audience is blind. Even space telescopes cannot save us. The James Webb Space Telescope, the Hubble Space Telescope, and others carry safety systems that forbid them from pointing too close to the sun. To protect billion-dollar instruments from destruction, they must look away just when Atlas burns brightest. Some observers hope that solar observatories like SOHO or STEREO, which use coronagraphs to block the sun's glare, may catch Atlas during its closest approach. But its trajectory never brings it close enough to the solar limb for these instruments to record. For Earth, the weeks of late October through early November will be a time of silence. This blackout lasts for nearly 5 weeks. In that window, the comet may change in ways we can only imagine. It may brighten to dazzling levels, it may fracture into shards, or it may dim suddenly as its volatile reserves collapse. All of it will happen beyond our sight, and when it finally reemerges in November skies, it will likely be fading, its story already told, its greatest secrets already spent in the fire. For astronomers, this is not just frustration, it is heartbreak. A once-in-a-lifetime visitor carrying chemistry from another star system, reaching its most volatile and revealing phase, and Earth will never see it. By early November 2025, the curtain begins to lift. As Earth moves in its orbit, the angular separation between the Sun and 3 Atlas slowly widens. At first, only the largest observatories will be able to detect its faint glow against the twilight sky. Weeks later, amateur astronomers will join the hunt, their telescopes once again finding the green halo of the interstellar visitor. But the comet that reemerges will not be the same as the comet that vanished. During conjunction, Atlas will have endured its closest brush with the sun. The heat will have stripped, reshaped, and possibly broken its nucleus. Outbursts may have carved away layers, jets may have blown open new vents, and its coma may have swelled to dimensions larger than ever measured. All of this will have happened while Earth was blind. When we see it again, it may be weaker, dimmer, its reserves of volatile ice largely exhausted. Its coma may shrink. Its once bright emerald glow may fade into pale mist. Or if it shattered under the sun's fire, it may return as nothing more than a cloud of fragments, drifting apart as they escape back into the dark. Predictions suggest it will not reach naked-eye brightness, even at its peak. At best, it may shine at magnitude 11 or 12, a faint smudge visible only through telescopes. To casual skywatchers, it may be invisible. To scientists, it will still be priceless. For even in decline, ATLAS will continue to carry data. Spectroscopic measurements may reveal how its chemistry changed under the stress of perihelion. Dust studies may capture the fingerprints of alien minerals, released as its structure collapsed. If spacecraft around Mars succeed, their observations can be cross-matched with Earth's post-conjunction data, stitching together the comet's missing chapter. By March 2026, ATLAS will drift past Jupiter's orbit. Distant spacecraft may glimpse it one final time, though from far greater range. After that, it will accelerate outward, leaving the solar system forever, carrying with it the last echoes of its alien birth. For astronomers, the frustration is undeniable. The greatest revelations may have happened unseen. But there is also perspective. We are lucky to have seen anything at all. Interstellar visitors are unimaginably rare, and in ATLAS, we have witnessed a comet that dared to break the rules. A body that glowed green, built an atmosphere half the size of the sun, and defied the physics of its own tail. When it is gone, the record will remain. Scattered light curves, patchwork spectra, images from Mars orbiters, fragments of data stitched together into a story. Incomplete, perhaps, but still enough to remind us of one truth. The galaxy is filled with worlds and fragments, each carrying chemistry we have never dreamed of. And sometimes one of them passes close enough to remind us how little we know. When Earth goes blind, we borrow other eyes. During superior conjunction, as three-eye ATLAS slips into the solar floodlight, only a scattered fleet of spacecraft can still reach for its fading signal. Their glimpses will be brief and imperfect, snapshots rather than the continuous heartbeat scientists crave. But in those frames may live the only record of what ATLAS becomes at its most extreme. Mars orbiters remain the best near-term bet. With flexible instruments and a favorable vantage, they can attempt spectra and imaging as ATLAS races past the inner system. Beyond Mars, our options thin. ESA's Bepi Colombo may catch opportunistic angles that Earth cannot, though its payload was built for Mercury's baked geology, not the delicate haze of a cometary coma. Parker's solar probe can taste the wind that shapes ATLAS's plasma, and in theory it might even feel a brush of ion tail. In practice, its cadence and sun-first priorities make systematic comet work unlikely. If it senses ATLAS at all, it will be as a whisper in the charged gale. Conjunction steals more than photons. It robs modelers of calibration. Simulations of outgassing, dust jets, and plasma tails are only as strong as the data points that anchor them. A 4 to 5 week blackout gouges a hole through the time series, exactly where the physics turns nonlinear. When Earth's telescopes return in late November to early December, they will not reacquire the comet we lost. They will meet what perihelion made. It may have brightened again, unfurling broader dust architecture visible to amateurs. It may have faded, its volatiles spent in the glare. It may have split, a string of fragile beads drifting down a hyperbolic arc. Recovery will demand choreography, updated ephemerides, wide-field scouts, fast handoffs between hemispheres. The sky position will have migrated. The brightness may be off by whole magnitudes. The shape may be unrecognizable. Meanwhile, public attention will ebb. No nightly portraits, no shareable crescents of green. The teachable moment, the tails, the jets, the shock, arrives offstage. That silence is its own lesson. Astronomy is not only what we can see, but what geometry forbids. Even our finest observatories bow to the sun. As elongation drops, safety interlocks seas pointing, and coronagraph fields fall short of ATLAS's path. The universe does not schedule revelations for our night. In the gap, theories proliferate, each elegant, each starving for proof. Is the green deepening? Did jets pivot? Did the anti-tail bloom or break? We will not know until the curtain lifts. What we can still capture are moments. A Mars orbiter spectrum catching molecules newly awakened, a high-phase image teasing the texture of a nucleus we have never resolved, a plasma spike sketching the invisible magnetotail. Snapshots, yes, but stitched together, a story. Inside the glare, the real trial awaits. Perihelion. Temperatures spike, ices cross thresholds, stresses climb. Objects either endure, flare, or fail. Atlas carries chemistry we have never seen awakened in sunlight before. Soon, we discover which fate it chooses. Hidden inside the sun's brilliance, 3i Atlas approaches its moment of reckoning. On October 29 to 30th, 2025, it will reach perihelion, sweeping past at roughly 1.36 astronomical units, just inside the orbit of Mars. No telescope on Earth will see it. No human eye will follow its transformation. And yet, the physics is inexorable. This will be the crucible that decides its fate. At perihelion, velocity peaks at an almost unimaginable 68 kilometers per second, more than twice Earth's orbital speed. Kinetic energy, carried for millions of years through the galaxy, slams against the sun's heat. The nucleus, an alien body of ices and dust, meets conditions it has never endured. Models predict fireworks. Carbon dioxide, dominant in Atlas's chemistry, sublimates explosively under heaves water ice far behind. Dust jets could erupt like fountains, thousands of kilometers long. The already vast coma may balloon still further, dwarfing entire planets. The eerie sunward plume, the anti-tail, could sharpen, branch, or even fracture into multiple structures, revealing secrets of the comet's rotation and interior. But perihelion also courts destruction. Comets are fragile, rubble piles bound by little more than weak gravity and frozen glue. As heat penetrates and pressures build, nuclei can shatter without warning. Atlas may split into fragments, each a shard of an alien world, scattering like cosmic breadcrumbs across its hyperbolic path. If it survives, it may emerge transformed. Green glow deepened, new molecules fluorescing, perhaps even unexpected colors flaring from exotic chemistry ignited for the first time in sunlight. If it dies, we may meet only a haze of dust in November skies, its nucleus gone, its secrets dispersed. The cruelest irony remains, we will not watch this climax. While Atlas burns, bursts, or blossoms, Earth is blind. Only after the curtain lifts, when it reemerges from conjunction in December, will astronomers learn which outcome unfolded. Will it be a survivor, stranger, and brighter than before? Or will they chase fragments and fading embers? Perihelion is not just a turning point in the comet's orbit. It is the defining moment of its story, a meeting of alien chemistry and our sun's fury. And whatever happens there will determine what Atlas becomes in the weeks, months, and perhaps millennia to come. To understand why 3i Atlas matters, we must set it against the backdrop of the only two other confirmed interstellar wanderers in history. The first was Oumuamua, discovered in 2017. At first, it seemed to be an asteroid, small, dim, and devoid of a coma, but soon it revealed itself as something far stranger. A spindle-shaped body, nearly 400 meters long, accelerating in ways gravity could not explain. No gas jets were seen, no tail trailed behind it, yet it drifted faster than physics allowed. Some called it a comet, hiding its activity. Others dared to whisper of technology, sails, or alien machines. Oumuamua left more mysteries than answers, vanishing into the dark without ever revealing its true nature. 2 years later came 2i Borisov, discovered by amateur astronomer Gennady Borisov. Unlike Oumuamua, Borisov looked familiar, a fuzzy ball of ice and dust, with tails like a textbook comet. But on closer study, it too betrayed its alien origin. Its gases were rich in carbon monoxide, far more than typical solar comets, hinting at birth under very different conditions. Where our comets carry water as their main ingredient, Borisov carried the fingerprints of another star system, its chemistry marked by temperatures and processes our solar nebula never knew. Together, these two visitors painted the first strokes of interstellar diversity. One long, enigmatic and silent, the other bright, active, and yet chemically foreign. Both prove that the galaxy sends us emissaries with wildly different natures, shaped by alien suns, alien skies, alien dust clouds, and now comes Three-Eye Atlas, an intruder that dwarfs their mysteries. Its sunward anti-tail, its violent CO2 dominance, and its sudden brightening have already shattered expectations. Where Oumuamua was a ghost and Borisov a foreign cousin, Atlas is something else entirely. An unclassifiable being whose very existence stretches the models of cometary science to their limits. This new arrival forces the question, are these objects rare miracles, or is the galaxy alive with wanderers, each stranger than the last? The story of interstellar objects is short, just 3 confirmed visitors in less than a decade, but each one has widened the frontier of what we thought possible. And in this gallery, Three-Eye Atlas stands apart. Where Oumuamua confounded us with silence and acceleration, Atlas overwhelms us with excess. Its coma, so vast it dwarfs most comets observed in human history, makes its nucleus nearly impossible to measure. Estimates range from 300 meters to more than 5 kilometers, an uncertainty so broad it reflects our ignorance of how such bodies behave. Where Borisov showed chemical quirks, carbon monoxide in strange abundance, Atlas redefines alien chemistry. The James Webb Space Telescope and other observatories confirm a dominance of carbon dioxide unseen in solar comets. Here is a body whose birth conditions must have been radically different, perhaps orbiting a cooler, dimmer star, or forming in regions where CO2 was the ice of abundance and water an afterthought. Its anti-tail breaks even deeper rules. For centuries, every comet studied by human science followed the same law. Dust and gas stream away from the sun, pushed by radiation and wind. Atlas points matter toward the sun, sculpting a geometry that mocks the very foundations of comet physics. No interstellar visitor, not even the enigmatic Oumuamua, has dared to disobey the rules so boldly. And then there is its speed. Atlas cuts through space with a hyperbolic excess velocity of 39 kilometers per second, faster than either of its predecessors. This suggests a violent past, perhaps ejected from a massive star system or hurled outward by a chain of gravitational encounters across the galaxy. It is, quite literally, a stone flung with extraordinary force across interstellar time. Together, these traits mark Atlas as a creature of extremes: larger, brighter, faster, stranger. If Oumuamua was a whisper and Borisov a familiar accent from a foreign tongue, Atlas is a voice shouting in dialects we have never heard before. And so the pattern emerges. Each interstellar object not only adds to our catalog, but demolishes the idea that these visitors should conform to any normal. Instead, they show us that the galaxy is teeming with diversity, with chemistries and structures that defy prediction. Atlas is not just a comet, it is a messenger reminding us how little we know about the worlds beyond our sun. The moment has arrived. After millions of years adrift between the stars, Three-Eye Atlas plunges into its most perilous trial, perihelion, the closest approach to our sun. On October 29 to 30th, 2025, hidden deep in solar glare, it will pass within 1.36 astronomical units, a distance where the sun's fury reaches its peak. Here, velocity becomes unimaginable. Racing at nearly 68 kilometers per second, over 152,000 miles per hour, Atlas streaks past the sun with energy so immense that every grain of dust, every trapped molecule of ice, is forced to reckon with the laws of physics. The comet's nucleus, a fragile body born under alien skies, now faces radiation and heat unlike anything in its long interstellar journey. Temperatures soar. Carbon dioxide, already the dominant volatile, erupts in violent outbursts. Jets blast outward like geysers of alien fire, spewing dust and gas thousands of kilometers into space. The coma swells to monstrous proportions, shimmering with strange colors, as new molecules hidden deep in the nucleus ignite in ultraviolet light for the first time. And yet destruction lurks as close as transformation. Comets are brittle worlds, weakly bound, fissured, and porous. At perihelion, the stresses are merciless. Thermal gradients tear at the interior. Explosive outgassing builds pressure beneath fragile crusts. In an instant, the nucleus could fracture, splitting into shards that scatter along the orbit like glowing embers of a broken world. Some models predict exactly that fate: fragmentation into multiple bodies, each carrying pieces of Atlas's story. Others suggest it may endure, scarred but whole, emerging brighter and stranger than before. The tragedy and the irony is that no one on Earth will see it. At the climax of this interstellar drama, our planet is blind. Hidden behind the sun's blaze, the comet's greatest transformations unfold in secrecy. The universe stages its spectacle without an audience. But when Atlas returns to view in December, it will not be the same. Whether in fragments or as a survivor reborn, it will carry the scars of its passage through the solar inferno, forever changed by the crucible of perihelion. When 3I Atlas emerges from behind the sun in late November or early December 2025, it will no longer be the same object that disappeared into the blaze weeks earlier. The question is not whether it changed. It must have. The true question is, how? If the nucleus survived intact, astronomers may witness a comet transformed into a cosmic spectacle. The coma could expand to unprecedented size, dwarfing earlier dimensions, its gases fluorescing with colors never seen before in any comet. Molecules buried deep within the alien core, organic compounds, exotic ices, carbon-bearing fragments, may reveal themselves for the first time, producing a kaleidoscope of emissions across the spectrum. Its mysterious anti-tail, already baffling, may evolve into an even stranger geometry: multiple tails splitting in opposite directions, dust and gas tracing out patterns that challenge the very foundations of cometary physics. But if perihelion brought destruction, what rises in December skies may be only fragments, a dozen, perhaps more, glowing shards scattered along its orbit, each carrying a piece of an alien world. For astronomers, this would be a treasure: fragments exposing interiors never meant to see sunlight, natural core samples from a body born around another star. For the public, it would be a vision of haunting beauty, shards of a visitor dissolving into the solar wind. The danger lies in ambiguity. Even with the best telescopes, it may be difficult to tell whether Atlas has survived or perished. Did its fading brightness mark depletion of volatile stores? Or did it simply shed dust too fine to reflect? Did new tails mark renewal or the disintegration of structure? Whatever emerges, one fact is clear: perihelion is a boundary. Before it, Atlas was an interstellar messenger carrying untouched chemistry from another star system. After it, Atlas will be something else entirely, reshaped, rewritten, perhaps even destroyed by the power of our sun. It is here, in this moment, that the comet's destiny crystallizes, whether as a survivor with scars of fire, a swarm of glowing fragments, or a fading ghost already dissolving into night. And only time will tell which story the December sky will choose to reveal. The story of interstellar visitors is young, but it is rewriting astronomy faster than any field in modern science. Before 3I Atlas, there were only two cosmic messengers that slipped into our system uninvited, leaving questions that still burn. The first was Oumuamua, discovered in October 2017. At first glance, it looked like an asteroid. No coma, no tail, nothing to mark it as a comet, yet its motion betrayed it. Oumuamua accelerated as it left the sun's grip, but no jets of gas or dust explained why. It was a ghost of stone, elongated like a cosmic shard, perhaps 400 meters long, tumbling through space, breaking every expectation. Was it a fragment of a shattered planet, an exotic ice body shedding invisible hydrogen, or, as some whispered, a crafted sail riding starlight? Oumuamua left as suddenly as it came, vanishing into darkness, its secrets intact. Then came 2I Borisov, discovered in August 2019. Unlike Oumuamua, it looked familiar: a glowing coma, a dust tail streaming into space, a comet, plain and clear. But even here, the strangeness lingered. Borisov carried unusually high levels of carbon monoxide, unlike anything in comets born in our system. It was alien, but recognizable, a cousin from another star carrying chemistry written in foreign skies. Between them, these two visitors shattered complacency. They showed that the galaxy does not deliver a single type of traveler, but many: the silent shard, the chemical cousin, and now Atlas. With the arrival of Atlas, the scale of diversity explodes. Its enormous coma, its CO2 dominance, its sunward anti-tail all make it a phenomenon without precedent. If Oumuamua whispered mystery and Borisov offered familiarity wrapped in difference, Atlas roars with complexity. It forces us to confront a new truth. The galaxy is not uniform. Each star system forges worlds in its own way, imprinting unique chemistries, unique structures, unique destinies. And these objects, when hurled across interstellar gulfs, arrive as messages written in the languages of alien suns. In the growing archive of interstellar visitors, Oumuamua, Borisov, and now Atlas form a trinity of cosmic anomalies. But Atlas is not simply another entry in the catalog. It is the one that breaks the patterns. Oumuamua was small, so small it slipped past us almost unnoticed. No coma, no tail, just a shard gliding silently through the inner system. Its mystery was in its absence, the things it didn't show. Borisov was the opposite, a comet through and through with a coma and a tail behaving like something we knew. But its chemistry betrayed its alien heritage: carbon monoxide in excess, volatile balances never seen before. Atlas, however, refuses classification. Its coma is monstrous, so large it hides the nucleus itself. Its chemistry is radical, dominated by carbon dioxide in ways that defy every solar system rule. And its anti-tail, a plume pointing toward the sun, has no precedent at all. Even its speed sets it apart. With a hyperbolic excess velocity of nearly 39 kilometers per second, it moves faster than either Oumuamua or Borisov. This isn't a chance traveler. It's a projectile, flung with force from a stellar nursery or hurled outward by violent gravitational encounters far, far from our skies. Each interstellar visitor has forced science to expand its imagination. Oumuamua proved they can be silent and invisible. Borisov proved they can look familiar yet carry alien chemistries. Atlas proves they can be utterly unpredictable, rewriting physics in real time. If Oumuamua was a whisper and Borisov a conversation, Atlas is a shout across the galaxy. It tells us that the Milky Way is teeming with diversity, that no two visitors will ever be the same, and that for every Atlas we see, there may be hundreds more slipping through the void, each stranger than the last. The lesson is stark. Interstellar objects are not rare curiosities. They are emissaries, and Atlas is the loudest messenger yet, one that forces humanity to rethink what drifts between the stars. Science thrives on answers, but with 3 Atlas, the questions are multiplying faster than the data. Behind every image, every spectrum, lies a contradiction, an enigma that refuses to settle into clarity. The first debate is about size. Observations from the Hubble Space Telescope suggest a nucleus somewhere between 300 meters and 5.6 kilometers in diameter. That margin of error is not a detail, it is a chasm. A body on the smaller end would be fragile, prone to disintegration. A body on the larger end would be massive enough to survive perihelion intact. The difference between those two outcomes is the difference between survival and annihilation. Then comes composition. Space-based spectroscopy insists on a carbon dioxide-rich nucleus, with CO2 levels surpassing water vapor, something unseen in solar comets. But ground-based telescopes complicate the story. They detect traces of cyanide, organics, and other molecules that don't fit neatly into the CO2 dominance narrative. If Atlas is so rich in carbon dioxide, why did its coma glow green in September, an effect usually linked to diatomic carbon, not CO2? Are we missing key ingredients? Or is Atlas running chemistry we do not yet understand? The anti-tail remains the most haunting riddle. By every law of comet physics, dust and gas should stream away from the sun. But Atlas defies that law, throwing material sunward as if mocking centuries of observation. Some scientists invoke dust grain dynamics, large particles launched fast enough to resist radiation pressure. Others point to plasma physics, suggesting that electromagnetic forces are sculpting the coma in ways we've never seen. Still others whisper about rotation states, with outgassing focused into strange asymmetric jets. Even rotation itself is a mystery. Astronomers search for periodic light curves, the telltale flickers of a spinning nucleus, but Atlas shows no clear signal. Is it rotating too slowly to measure, too irregularly to reveal a rhythm, or is its shape so spherical that spin leaves no trace in its brightness? And then, the brightness surged. In September, Atlas brightened more than models predicted. Some reported dramatic increases, others more modest. The data is inconsistent, scattered, riddled with error bars. But the message is clear. Atlas refuses to behave like a normal comet. Its very origin compounds the uncertainty. Tracing its path backwards suggests birth somewhere in the Milky Way's thin disk, a region thick with stars and newborn planetary systems. But the uncertainties in its orbit grow enormous as we extend further into the past. Was it born around a cool, dim star where CO2 dominated ice formation? Or did it drift for eons through interstellar dark, reshaped by cosmic rays and collisions until it became the anomaly we now see? The truth is, Atlas is a detective story with half the pages missing. Astronomers hold fragments of evidence, but the most critical chapter, its hidden passage through perihelion, remains unread. With 3i Atlas, astronomy finds itself trapped in a paradox. A comet too bright to ignore, yet too strange to fully explain. The gaps in data, especially during solar conjunction, leave room for theories to multiply, each competing to claim the truth. One school of thought focuses on chemistry. The James Webb Space Telescope paints a picture of a carbon dioxide-dominated object, unlike any comet in our solar system. But ground-based observations refuse to stay silent. They whisper of cyanide, organic molecules, and perhaps even exotic hydrocarbons. If Atlas is truly rich in CO2, how can it simultaneously produce emissions usually linked to complex organics? The result is a chemistry puzzle. Is it a pure CO2 comet, or a chaotic mixture of ices and compounds layered by some alien process of formation? Then comes the green glow. Traditionally, that emerald light is the signature of diatomic carbon, C2, formed as sunlight tears apart carbon-bearing molecules. Yet, the direct chemical sources for such emission appear scarce in Atlas. Did its coma chemistry shift suddenly as it crossed a solar threshold? Or is something stranger at work? Perhaps the breakdown of unknown complex organics from its star system of birth? The anti-tale inspires its own battles. Conventional models say large dust grains flung sunward with high velocity can resist the push of solar radiation. Plasma physicists argue otherwise, suggesting electromagnetic interactions between the solar wind and Atlas's coma sculpt streams of charged particles into defiant geometries. A few even propose rotational asymmetries, where jets erupt only from specific regions of the surface, launching dust toward the sun in defiance of cometary norms. No consensus exists. Each explanation clashes with observations, leaving the puzzle unsolved. Even the question of rotation divides researchers. Light curve analysis has failed to reveal a clear period, suggesting Atlas might rotate so slowly that its cycle remains invisible, or so chaotically that no rhythm can be extracted. Some propose it may be tumbling, its orientation changing unpredictably. Others argue its nucleus is simply too round, its brightness too uniform to betray its spin. But rotation is no trivial detail. It controls outgassing, jet formation, and even structural survival at perihelion. Without it, models are blind, and so the debates swirl. Is Atlas a fragile rubble pile barely holding together, destined to shatter under solar stress? Or is it a monolithic survivor, a hardened shard of alien ice forged under conditions our solar system never knew? Every telescope, every simulation offers only fragments of the truth. The comet's disappearance into solar glare, leaves theorists arguing in the dark, building castles of speculation on incomplete foundations. The cruel reality is this: the answers lie hidden in the one moment we cannot watch, the crucible of perihelion. When Atlas returns to view, it may confirm one camp's predictions or it may tear them all down, forcing astronomers to start again. Before imagination leaps to alien technologies or exotic physics, science demands restraint. Three-Eye Atlas may be bizarre, but perhaps it is simply a comet. Strange, yes, but still bound by the rules of nature. The first clue lies in its carbon dioxide-rich chemistry. Unlike solar comets, which are dominated by water ice, Atlas seems to have formed in a colder, more distant environment where CO2 froze while water remained vapor. In such a birthplace, perhaps around a dimmer, cooler star, the natural outcome would be a comet where CO2 is king. This alone could explain its extraordinary activity. Carbon dioxide sublimates far more readily than water ice, driving outgassing at great distances and producing the immense coma seen in September. The green glow, puzzling at first, may also have a natural origin. As sunlight breaks apart carbon dioxide and carbon monoxide, it can liberate atomic carbon, which recombines into diatomic carbon molecules, C2. These fluoresce with the same eerie green hue familiar in solar comets, but triggered here by a different chemical pathway. No exotic processes are needed, just chemistry unfolding under alien conditions. The anti-tail, too, could have an earthly explanation. Dust dynamics are more complex than simple away from the sun rules. If Atlas ejects large, heavy grains at high speed, they can travel sunward, resisting the pressure of solar photons. In this view, the anti-tail is not a violation of physics, but a showcase of its subtleties: size, velocity, and orientation conspiring to bend the rules in unexpected ways. Even the brightness surge might be explained without mystery. A highly porous nucleus riddled with voids could allow heat to penetrate deeper than expected. As hidden pockets of volatile ices awakened, they erupted in sudden waves, flooding the coma with fresh material. The result: rapid, dramatic brightening that models built for denser, water ice comets could not predict. Slow rotation could amplify these effects. A nucleus that spins sluggishly would bake on its day side, concentrating outgassing into narrow regions. Jets focused in these hotspots might drive dust sunward or cause sudden brightness changes. Nothing supernatural, just the normal laws of heat, ice, and spin playing out in alien combinations. So perhaps Atlas is not a messenger of impossibility, but of diversity. A comet formed in conditions foreign to our system, behaving in ways that look alien only because our experience is limited. Its strangeness is a mirror, reflecting how little of the galaxy we truly know. Beyond chemistry, the mysteries of Three-Eye Atlas may still bow to natural processes, though ones pushed to extremes never witnessed before. One candidate lies in the strange realm of plasma physics. When sunlight strikes Atlas's coma, gases become ionized, turning into a charged plasma that interacts with the solar wind. These invisible electromagnetic forces can sculpt dust and gas into filaments, arcs, and even streams that appear to move toward the sun. What looks like defiance of cometary law may simply be plasma dynamics magnified by Atlas's unusual chemistry and intense outgassing. The comet's structure itself could explain much of the chaos. If Atlas is a rubble pile, a loose collection of icy fragments weakly bound by gravity, then solar heating could destabilize it rapidly. Cavities within such a porous body would allow heat to penetrate deep, igniting buried ices and triggering unpredictable bursts of activity. Each flare of brightness, each jet of gas, might be the surface cracking open to reveal hidden reservoirs of volatile material. Alternatively, Atlas could be a monolithic survivor, a solid block of exotic ice and dust hardened by its interstellar journey. In this scenario, its stability allows it to withstand stresses that would destroy weaker solar comets, enabling it to sustain its colossal coma and anti-tail far longer than models predict. The journey itself may have shaped it. For millions of years, Atlas drifted through the interstellar void. bombarded by cosmic rays, battered by micrometeoroids, frozen and thawed in cycles as it passed through star fields and nebulae. Each event left scars, altered chemistry, and weakened or strengthened layers of its nucleus. By the time it reached us, it was no longer the comet that left its home star. It was something transformed by the deep dark between suns. Put together, these processes may explain every mystery. The CO2 dominance sets it apart, but not beyond nature. Plasma physics accounts for its rebellious anti-tail. Porosity and rotation explain its bursts of brightness. And interstellar processing provides the finishing touch, reshaping it into the alien yet natural object we now observe. In this view, Atlas is not breaking the rules. It is teaching us that the rules are broader than we imagined, that cometary science has only ever been tested on a small sample drawn from a single solar system. Atlas widens that field, showing us how nature operates when the universe itself is the laboratory. There are moments in astronomy when the data is so strange, so uncooperative, that speculation spills over the boundaries of science. 3i Atlas has become one of those moments. Its vast coma, its impossible anti-tail, its surges of brightness, each invites whispers of explanations beyond the natural. The most enduring of these is the alien technology hypothesis. Ever since Oumuamua baffled astronomers in 2017, some have wondered whether interstellar objects might be artifacts, not accidents. Could Atlas be a dormant probe, its sudden brightening a system activating under solar power? Could its anti-tail be a directed exhaust or transmission, rather than dust? It is a tempting story, one that resonates with humanity's oldest question: are we alone? Yet the evidence resists it. Every spectrum taken so far reveals nothing but natural volatiles, carbon dioxide, traces of water, organics. No metals, no alloys, no signals inconsistent with ice and dust. If it is a machine, it hides its nature too perfectly. Other theories drift into the realm of the fantastic. Some suggest Atlas may be a plasma life form, a self-organizing cloud of charged particles sustained by the sun's energy. In laboratories, dusty plasmas have shown lifelike patterns, self-replication, movement, even evolution under certain conditions. Could Atlas be such a being, scaled to celestial proportions? If so, its strange tails and brightness might be the pulse of something alive, but not in any sense we recognize. Another fringe idea, the scout hypothesis. In this telling, Atlas is no accident of ejection, but an intentional surveyor, carrying data across interstellar space. Its coma becomes a sensor field, its anti-tail a communications array, its green glow a signal of activation. If true, it is not just a messenger from another star, but a messenger for another civilization. Still others venture into the truly unthinkable, exotic matter. Could Atlas contain materials unknown to physics, substances interacting with gravity or energy in ways beyond our models? Might its behavior be the first whisper of new physics, evidence of processes not yet imagined? And then the most daring speculation of all, time itself. What if Atlas is not from another star, but from another era? A relic flung backward through time, carrying messages or matter from a future we cannot yet comprehend. Its anomalies would then be not alien, but temporal, shaped by laws of causality we have not mastered. Science is skeptical, and rightly so. History reminds us that mystery often yields to mundane truth. Pulsars mistaken for alien signals became neutron stars. Fast radio bursts turned out to be astrophysical events, not coded transmissions. Yet the value of these exotic theories lies not in their probability, but in their imagination. They remind us how profoundly unusual Atlas is, that it can stretch human thought beyond the comfort of the known. Beyond the boundaries of the possible, speculation does not stop at alien probes or strange plasma behaviors. For 3i Atlas, some of the most imaginative theories venture even further into the unknown. One of these is the living plasma hypothesis. In controlled laboratories on Earth, scientists have watched dusty plasmas, clouds of charged particles, form patterns that seem eerily lifelike. They ripple, They replicate, they evolve in ways that mimic biology without being alive in any traditional sense. Could Atlas be a vast, cosmic scale version of this phenomenon? Its bursts of activity, its anti-tail, even its sudden brightening could be the pulse of a plasma organism awakening in the electromagnetic fields near our sun. If true, Atlas would not just be a comet, it would be a form of life beyond carbon, a being born not of chemistry, but of physics itself. Then there is the exotic matter hypothesis. Some physicists imagine forms of matter beyond our current science, particles or states that interact with energy and gravity in ways we have never observed. If Atlas contains such material, it could explain its strange acceleration, its unusual tails, or its hyperactive chemistry. Perhaps what we see as outgassing is instead a kind of energy release from matter unknown to Earth, the first hint of a physics that lies beyond the standard model. The boldest speculation of all is the temporal anomaly theory. What if Atlas is not only from another place, but from another time? A relic hurled backwards across epochs, carrying within it fragments of knowledge or warnings from a future yet to come. In this vision, its green glow is not mere fluorescence, but a message encoded in light. Its unpredictable behavior becomes not accident, but design. The comet would then be not just interstellar, but intertemporal, a messenger that defies causality itself. None of these ideas rest on firm evidence. Spectra show normal molecules, carbon dioxide, water, organics. Observations reveal dust and plasma consistent with known processes. Yet the very fact that Atlas provokes such speculation speaks to its power. Rarely has a celestial object pushed human imagination so far beyond the edge of science. If history is a guide, the true explanation may ultimately lie in natural physics, operating under conditions we have never before witnessed. But for now, Atlas sits in the twilight between science and wonder, reminding us that the universe is not only stranger than we know, it may be stranger than we can know. The clock is ticking. Every orbit, every calculation narrows to a handful of critical dates that will define the legacy of 3i Atlas, not just for astronomers, but for humanity's understanding of the galaxy itself. The first milestone comes on October 3rd, 2025, when Atlas makes its closest approach to Mars, skimming past at about 30 million kilometers. For the spacecraft orbiting the red planet, Mars Express, MAVEN, the Trace Gas Orbiter, and the Mars Reconnaissance Orbiter, this is a once-in-a-lifetime chance. Designed for planetary science, not comet hunting, their instruments will be stretched to the limit. Yet if Atlas remains bright, they may capture images of its nucleus, its jets, even its strange anti-tail, offering data no Earth telescope could see. Then comes the climax, perihelion on October 29-30. At 1.36 AU, Atlas plunges into the sun's fiercest heat, racing at nearly 68 kilometers per second. Here lies the moment of transformation. Will it survive? Shatter? Blaze into unprecedented brilliance? Ironically, it will do so unseen, hidden behind solar glare at the instant when its story burns brightest. The silence deepens in November. For nearly 5 weeks, Atlas vanishes, unreachable from Earth. This is the dark gap in the record, when theory replaces observation and astronomers can only wait. They know it is changing, they just cannot see how. And then, December 2025, the comet reemerges into the night sky, visible once more to telescopes on Earth. But what will return? A survivor, scarred but magnificent, a handful of glowing fragments scattered along its orbit, or nothing more than a faint haze, the ghost of a world undone? Every possibility carries meaning. A survivor will reveal chemistry never before seen. A fragmented body will expose its inner layers, natural core samples from an alien star system. A fading ghost will remind us of the fragility of interstellar travelers. In the months that follow, the story continues. By March 2026, Atlas passes near Jupiter, where spacecraft like Juno or Europa Clipper may catch a distant glimpse. By then, it will already be leaving, drifting outward forever, never to return. These dates mark more than a comet's passage. They are checkpoints in a cosmic experiment, an interstellar body tested by our sun. And for humanity, they are opportunities to witness, measure, and learn. Because once Atlas is gone, it is gone forever. Whatever fate 3 Atlas meets, whether survival, fragmentation, or fading into obscurity, the implications reach far beyond one comet. Each outcome is a message, not only about Atlas itself, but about the galaxy we live in. For science, Atlas is a laboratory of extremes. If it survives perihelion, astronomers will study how carbon dioxide-rich comets behave under solar fire, challenging assumptions based on water-dominated bodies from our own system. If it fragments, each shard becomes a window into its interior, samples of a world formed around another star, preserved across millions of years of interstellar travel. If it fades quietly, the lesson will be just as valuable. Even interstellar giants can be fragile, dissolving before our eyes. For planetary science, Atlas reveals diversity on a galactic scale. It shows us that our solar system is not the rule, but one example among countless possibilities. Other suns forge other chemistries, other architectures, other kinds of worlds. And when those worlds are flung into interstellar space, they carry the fingerprints of their origins. Atlas is such a fingerprint, alien, distinct, and irreplaceable. For technology, its arrival exposes the limits of human readiness. We discovered Atlas only months before its perihelion. There was no chance to send a spacecraft, no mission fast enough to meet it. Future observatories like the Vera Rubin Observatory promise earlier detection, perhaps years in advance, making it possible one day to intercept such a visitor. Atlas reminds us, the galaxy sends messages, but we are rarely prepared to read them. For philosophy, Atlas is a mirror. It forces us to confront how small and local our knowledge truly is. For centuries, comets were thought of as omens, as icy wanderers, as relics of our own solar system. Atlas proves they can be something else entirely, emissaries from other stars, bringing with them questions bigger than any single science can answer. And for humanity, it is a story of wonder. Few alive today will ever see another confirmed interstellar comet. Each is a reminder that the cosmos is not a static backdrop, but a living theater, dynamic, unpredictable, and vast beyond comprehension. In the end, Atlas may leave behind more questions than answers, but perhaps that is its greatest gift. For in its strangeness, it has expanded the borders of human imagination. It has shown us that the universe will not be neatly cataloged, that beyond every horizon lies a mystery waiting to break the rules. And so, as Atlas races outward toward the galactic dark, it leaves us with the most profound implication of all. We are not the center, not the measure, not the limit. We are simply observers, witnesses to wonders that pass once and never again. In the end, 3 Atlas is more than just a comet. It is a traveler from beyond our sun, a wanderer shaped by alien skies, carrying within it the chemistry of another world and the mysteries of another time. It has tested our instruments, challenged our theories, and stretched the very limits of imagination. We watched it brighten against the darkness. We puzzled over its impossible anti-tale. We debated its volatile chemistry, its hidden structure, its uncertain fate at perihelion. And though we were blind at its most critical moment, we know one truth: Atlas will not leave us unchanged. For scientists, it is a reminder that the galaxy is a laboratory too vast to comprehend, and that every visitor teaches us something new about the universes beyond our own. For humanity, it is a whisper that we are not alone, not necessarily in intelligence, but in diversity. Other systems build other worlds, other comets, other mysteries, and they pass through our skies like cosmic postcards from distant suns. Soon, Atlas will fade. It will sweep outward on its hyperbolic path, leaving the solar system forever, vanishing into the galactic dark from which it came. We will not see it again, but its memory will remain, in data, in images, in the awe it left behind. And perhaps that is its true message, that the universe is not finished surprising us. That wonder is not an exception, but the rule. that every horizon hides another mystery waiting to arrive. So, as Atlas departs, let us carry its lesson with us, that we live not in isolation, but in a galaxy alive with travelers, that we must keep watching, uh, keep asking, keep reaching, because the next visitor is already on its way. And that was just a glimpse into the mysteries of our universe. If you enjoyed this journey, don't forget to like, subscribe, and join us for more cosmic explorations only here on the Sleepy Space Explorer.